Okay, Assalamu alaikum. So today we are going to talk about module 3, and in module 3 we are going to talk about the operations and the discrete Fourier transform for image processing. So in this week, which is week number 8, we are going to talk about morphological operations. So first of all, this is how it's going to be. Week 8 we're going to talk about the morphological operations. Then we are going to talk about the frequency domain image processing in part 1 and frequency domain image processing for part 2. We are going to cover 2 course learning outcomes during this module. So what do I mean by morphology? Is a branch of biology that deals with the form of structures of the animals and planets. So morphological image processing is used to extract image components for representing and describing region shapes such as boundaries, skeletons, and convex hull. So first of all, the mathematical framework used is pre-processing the image, filtering the image from the noise, sharpening simplification or shape simplification, then enhance the image structure or object structures using skeletonization or convex hull. Then we need to find the quantitative descriptions such as area and parameters, which we are going to describe in module number 4 when we talk about the feature extraction. So some basic information theory. Here we have the two sets A and set B. This gray part is A union B, so it's all of the images. This is A intersection with B, so this is the intersection of A and B. This is A complement. This is A minus B, so it's the complement of B and A, so we are going to find it like A minus B. Now, reflection is basically the set of B denoted by B dash is defined as the reflection. So B dash is the set W where W is minus B. So the reflection is the minus of B where B is part of the larger set B. The translation of set B by a point Z. So we want to move point B to a point or translate it by Z points. So Z1 and Z2 denoted by B of Z is defined as B of Z is equal to C, where C is equal to B plus Z. So we move the image. We translation the image. We do a translation for the image again where B is part of the big B component. Now if this is B, this is the reflection of B, so this is minus B, and this is the translation of B with a point Z1 and Z2. So this is how you move an image and this is how you transform an image. Now we have another thing which is called the structural element. It's a small set of sub-images used to probe an image under a study for properties of interest. So it's called a structural element or SE. We have different types of structural elements. We have different types of structural elements. It can be looking like this. This is a common type, which is the box. It can be like this. It can be like this. And of course, when we talk about a structural element, okay, when we talk about a structural element, okay, so the structural elements, as you can see over here, is like a plus sign, but it will need to be enclosed in a 3x3 image. So this is also a 3x3 image, and also this one is fine. But for this structural element, we need to finish it up like this, and we will end up with a 7x7 structural elements. Now, this is the origin where things are going to happen in the origin. So the origin, like we did earlier, needs to be on top of the pixel that we are concerned about. So examples of structural elements. So in figure A, we have a set of shaded shaped squares in membership of set A. B is the structural element, so B is going to be the structural element. Then we're going to pad the image. Since B will be like something like this, if I draw B, B will be having the value looking something like this. Okay, so we need to pad A. So we need to pad A so that the structural element can be all within the image, as you can see over here. This is our structural element. So the set of padded background is shown over here, and this is our structural element which will be moving around the image. Now, first of all, the morphological operations, you need to remember that all operates on the binary images. Okay, it all operates on binary images. Now, when we apply this structural element to the value, which is E is the process structural element, so it depends on what we are going to do with the image. So here we are doing the region of an image, and you can see the output as seen over here. We will discuss it later. Now, first of all, what is an origin? Origin is having first this symbol with A and B sets of Z square. The origin of A by B is denoted as all of B should be included of part of A. All of B should be included part of A. So the set of all points Z such that B translated by Z contained by A. So as we move B through A, all the points that include B in A should be included in the final image. So it's like the intersection of A complement with the intersection of BZ with A complement is equal to phi, which is an empty set. So for instance, if we have this element and we are going to move it, we start moving from here. So we start moving from here. So we are going to do the padding, and once we move it, we start to erode the image, and we end up with this value over here. Again, it's the same applies over here, where we want to make sure that all the pixels are available. So if you put this over here, okay, if you put this one over here, you are going to find that this is the output. So set number A, which is here, we have the set. Number B, image B, shows us the square element structure, which is this one. The origin of A by B is shown over here by the shaded area. This is the origin. Look, when you put the value here, and this is our pixel, the pixel will look something like this. Now, this part is not intersected between the element and the image, so this pixel will be out. The pixels will start counting from here, where all the image is counted. The same applies when we apply this value. The same applies when we apply this element over here. This element will start with the center pixel here, and the element will be looking something like this, and on top. So this part is not included, so all of these will not be included. The only parts that will be included is the center parts from here, the center parts from here to here, because these center parts will have the object all enclosed within the element. Okay, this is called the origin. For example, if I have this structural element and I have my image. So first of all, my structural element will be here. You can see that these pixels are not included. These pixels are not included within the original image, so nothing will be happening here. Nothing will be happening here. Nothing will be happening here. Now, when you see this is only one pixel, you need all of the pixels to be included. So nothing here, and so on. When do we start having an actual image? So this pixel is counted. So this pixel 1, 2, 3, 4, 1, 2, 3, 4. So this pixel will be included. 5 will be included. 6 is out. Then in this row, pixel number 3, pixel number 4, pixel number 5 is out. In this part, pixel number 3, pixel number 4 is out. Here, all of them are out. So we end up with this structural element, as you will see in the next slide. So this is our structural element, which is in the blue slides, and these green parts are the removed part of this image. Are the removed part of this image. Okay, so this is the erode element. Now, the erosion is useful because sometimes it can remove the noise, but if you have this is an original image, this is an origin by 3 by 3 element. This is by a 5 by 5 square structural elements. Of course, the structural elements may differ. So watch out in these examples. One refers to the black pixel, as you can see here, because these are the black pixels. So what are the erosion used for? It can split part joint objects, and it can strip away extrusions, and it can shrink objects. So we need to be careful about that. So this is an example of an erosion. As you can see, this is our original image. This is an erosion with a disk of radius 10 pixels. You can see we removed all of the connectors. This is an erosion with a disk of 5 pixels. And this is an erosion of a disk of size 20 pixels. And you can see here that the 5 kept some parts of the connections. The 10 removed the parts, and the 20 removed all the details on the sides of the image. So I'll stop here and we'll continue on the second part.